Hi, this is a lesson on reviewing factoring. This will be a quick review, and it's meant for people who have already had a lesson on factoring. It is not an introduction to factoring. It's just a review of the most common forms of factoring that you will find. Factoring. What is factoring? Factoring is just taking things that will multiply to get whatever your product is. If this is my product of 21, that's the product. What would be the factors? Well, two factors that make 21 would be 3 times 7. You could probably think of other factors for 21, like 1 and 21. Right? That's I think that's the limit of our factors. And factors can be written in any order. You could put them as 7 times 3 or 21 times 1. But if you wanted to list all the factors for 21, you would have to list 1, 3, 7, and 21. All right. So now we know what factors are. So if we try to factor this polynomial or this binomial, because there are two terms here, this binomial factors 2 x times x plus 3. The important thing to remember is when you're trying to factor, always look for the greatest common factor first, no matter what you're doing. Okay, that is the critical first step for factoring. All right. So what we can factor trinomials like this. There is no greatest common factor, so we can move on to some other step here. And this could be factored into x plus 1 and x plus 2. First thing to look for is the greatest common factor. If there are, then you must factor that out first. And the greatest common factor here would be a 2. And you factor out the 2, and you're left with x plus 5. All right, looking at this greatest common factor here, you can see that 3, but don't forget there's an x in every term. So it's actually 3x would be the greatest common factor. Okay, all right. Okay, factor by grouping. If you see 4 terms like this, think of it as doing 2 separate binomials. Think of it as just spreading them out into the first 2 terms as one binomial and the second 2 terms as one binomial. Then you would try and factor out the greatest common factor between these 2 binomials. And x squared is in the first binomial and 2x is in the second binomial. If this can be factored by grouping, then the 2 will have a common factor of x plus 3. So that you would just write x plus 3, and then the remaining terms go into the other set of parentheses. That makes the other factor. Now you can always check your work. You can distribute this out, or some people like to say FOIL. If you FOIL this back out, you should end up with what you started with if you factored correctly. Special products are like this. This is a special product. This is x squared plus 0x, even though we don't write the 0x, minus 9. This is a trinomial in a way. This is really a binomial, but you can think of it as a trinomial with a 0x term in the middle. But when you factor that, this becomes x minus 3 and x plus 3. That's a difference of squares. Now, a perfect square trinomial looks like this. It is actually a trinomial, and it can be factored as 2 identical factors. Okay, and we call that a perfect square because this is a perfect square because these 2 terms, these 2 factors can be written as a squared term. All right, let's move on to the x factor, x factoring. So here we go. If you have a quadratic expression, quadratic trinomial, here's an example of what that would look like, where a, b, and c are the coefficients in front of your variables. So this would be ax squared plus bx minus c. C is the one with the constant term without an x. b is the one in front of the x, and a is in front of the x squared. Make a great big X, and then you're going to put the a times the c on top of your x. Okay, so then in this case, be 1 times negative 12, gives you negative 12. And then you would put the remaining piece, the middle piece, down at the bottom, the b. In this case, it's a 1. Now you're going to come up with two numbers that multiply to give you a negative 12 and add to give you 1. So it happens to be negative 3 and 4. Remember, the product goes on top. The product of the two side numbers, negative 3 and positive 4, the product goes on top, and the sum goes on the bottom. You're going to add them. It does not matter whether you put the 4 on this side and the negative 3 on this side. The order doesn't matter, but just remember the negative sign has to go on the 3 because you're trying to add to get a positive 1. If you put the negative sign on the 4 to make that negative 12 with a positive 3, you're going to end up with a negative 1, which would be incorrect. Now the last step here is to divide by your leading coefficient a. Now, since this is 1, we can really skip this step, but I would like to show this step so that you can apply this rule to any trinomial. Okay, so you can divide both of these by a, which happens to be 1, which doesn't change these two factors. Now you just put them in parentheses with the x, and just put these two factors inside the parentheses. So you put x minus 3 and x plus 4. So those are the factors for this trinomial. And you can always check your work by foiling this out to see if you actually did it correctly. Let's look at another example. Okay, here's my quadratic trinomial where a is 2, b is negative 7, and c is negative 4. So here's my x. I need to put on top would be the a times the c, which will be negative 8. And then on the bottom, I would put the number that's left over, which is b, negative 7. Now I need to come up with two numbers that multiply to give me negative 8 and add to give me a negative 7. So I came up with negative 8 and a positive 1. It doesn't matter which side the negative 8 goes and which side the positive 1 goes, but the negative sign does have to go on the 8 to get a negative 7. If you accidentally put the 8 as positive and the 1 as negative, you're going to get a positive 7. That's one of the most common mistakes that students make on these kind of problems. So we have one more step. Since the leading coefficient a is not 1, we do have to divide those and reduce these two fractions. Okay, so negative 8 divided by 2 is negative 4. This one does not reduce, so we leave that as is. And we get x minus this 4. And then we get x plus 1. And we don't factor with fractions, so we take the denominator 2 and we put it in front of the x. The denominator goes to the front. Okay, don't put the numerator in the front. So this will be x plus 1/2, moving the denominator in front of the x. So you can check your work by foiling this out, and you should end up with what you started with. Okay, I'm going to show you one more. Try this one on your own. Pause the video, and when you come back, see if you did it right. All right, so you had a chance to try this one on your own, and I hope you got this. When I multiply a times c, I get a 6, and the leftover is that b is negative 5. And what makes 6 and a negative 5? We got to be careful. This is one of the most tricky combinations. A lot of people see this and they want to use a 1 and a negative 6 or a negative 6 and 1. But this is a positive 6. That combination will not work. That's a big mistake here because you're trying to make that negative 5. What does work is a negative 3 and a negative 2 makes a positive 6 and a negative 5. All right. I hope you didn't get caught there. All right. So then the last step here would be to divide by my leading coefficient, reduce the ones that can be reduced, and I get a -1. So now I get x minus 1, and then x minus 2 over 3. Over 3, move the 3 over, right? So that would be it. You can always check your work and see if you did that right. All right. So just to recap the 5 steps that makes this work, you put a times c on the top of the x and the b on the bottom of the x. And then you would have, that would be the first step. Second step is to find a product and a sum that makes this product, makes this sum. Okay. And then third step would be to divide by the leading coefficient. Make sure you reduce. Step 4. And step 5, write it in your parentheses, the 2 binomials. Remember to move the denominator in front of the x. So that's a recap of factoring trinomials or polynomial. I hope that helps. You can always send me any questions. And here are some links to other videos about factoring.